And hello, I think. I can see audio and I think there is a stream happening. YouTube says there is a stream. So first thing, can you see me? Can you hear me? I have no idea if this is working. Bob P, good morning. Frank, Chip, and who else was there? Henrik, Sion. We are live, video and audio is good. Thanks, Sion. Amazing. Okay. Before I get into anything else, I acknowledge the traditional owners of this land. I pay my respects to their elders past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. So, this is such a jerry-rigged sort of system. Yeah, so I've got OBS with all of the inputs from the cameras and things, so I can do things like switch to desktop and overhead camera and all of those sorts of things through OBS. But my microphone is going into the ATEM, so audio is going through directly, and then the ATEM is doing the streaming. So hopefully this is a step towards making this whole streaming setup a bit more reliable, which is great. What I really ultimately want to be able to do is run Fusion 360 on my desktop while I'm streaming and not have that make things freak out. I think the only way I'm going to be able to achieve that is to not be using OBS at all, but then I lose a bunch of capability. So we'll see. Now, Scott says can't see or hear him. Hopefully, okay. Yes, all right, so what is what almost came out of my mouth then? What is up, YouTube? All right, so Henrik had a question, and I just want to catch that before it scrolls way off the screen and I forget and lose where I'm up to. Henrik said, what do I think about the remote light switches sold on AliExpress in Estonia? One company sold this kind of stuff as well, but it was damn expensive and I can't remember the name anymore. Henrik, do you have a link to a specific product? Like if you've got an AliExpress product page or something, drop it into the chat and the link, like your thing will be held for moderation, but then I can approve it so that everybody can see the link, because then we can look at the specific product. There are many, many remote light switches sold on AliExpress, made by many different people, and yeah, it'd be nice to, if we're going to talk about it, we might as well be talking about the same thing. Stephen Jepson, how are you going? Still being in lockdown? That's a question for the audience. I'm personally okay, and what is there to say about it? It's annoying. I know many people are not dealing with it very well at all at the moment. We've had some protests and things here in Melbourne, and I will try to avoid that subject in general, but speaking for myself personally, I'm doing pretty much okay. So, and I hope everybody else is too. All right. Ooh, Austin says the package is almost there. So, by way of background, Austin of Austin's Creations has sent me a package with some open extensible rack system type related devices and things he's been working on and boards he's been building, and he has very, very kindly sent a package to me with some goodies for me to experiment with. And so what we're arranging is that I will do the package opening on the live stream probably next Sunday. So yeah, it's almost here. Oh, Sophie the cat is here. Hello. We've got lots of people here this morning. Thank you for coming along. All right, our Celtic Beast, David Howes, Jay After Dark. So that's Jax, I think, from Discord, if I've got the correct person. Now, today's live stream. The topic is squirrels, because I know I say this a lot, but this time I did actually begin the live stream with no plan whatsoever for what I'm going to talk about. Did I get the link? Henrik asked. No, I haven't seen anything pop up. Did you put it here in the YouTube chat, or is it in Discord or somewhere else? I should probably open Discord. I haven't opened Discord for a little while, so there will probably be a huge backlog of notifications. Opening Discord is always scary. And of course, every time I open Discord, it says, downloading update 1 of 3, update 2 of 3, update 3 of 3, starting. All right, in YouTube. No, I didn't actually see it. Normally what would happen is if you dropped a link in, if you're not a moderator, then the comment will be held and it won't be displayed, but I should see it. And then I'll be able to click approve, and then everybody else can see the link too. But no, I haven't seen anything at all. It's just not even there. I wonder if YouTube is silently blocking links and not allowing to be displayed even to moderators. That would be annoying, because I'd like to be able to approve it. Okay, now, sorry, just give me a moment while I shuffle things around on the screen here, get myself organized, because everything is kind of confusing. Because I've got this new ATEM set up. I've got different windows and things to what I normally have. I've got the ATEM control software, the YouTube stream management window, shifting stuff around. Okay, I think we're organized. Let's bring the chat back so I can see what's going on. All right. Oh, Bob P said, that appeared for me. I have not. That's strange. Where is the link? Bob CP says, okay, that it's there. I do not see the link. Sorry. I don't know what's going on. All right. Now, maybe we need some people in the chat to suggest a topic for the day. While we're thinking about what we're going to talk about today, I'm going to have a quick scroll through, and I'm going to go into Discord. Something that I originally wanted to do, I wanted to do a long time ago, was to have a spot, sorry, I'm scrolling down, a spot where like Patreon supporters and GitHub sponsors, etc., could have a private chat area and could ask questions and things for live streams. And I'm trying to find it. Controllers, firmware, tools, techniques, projects, financial supporters. Here we go. General. There's a live stream questions section. Let's see if there are any questions. Oh, okay. There is a question. There is. James O said, how do you do proto area on your board? Specifically, what component do you use in schematics? That is a good one. Okay, so Stephen W had a question. Why the answer to life, the universe, and everything is 42? Well, that is the question, isn't it? We know the answer, we just don't know what the question is. Roll said, a few weeks ago I mentioned lights turning on and off randomly. Plasma cutting, green wave, need a program manager. Okay, I've got lots of things. People have been coming up with suggestions on the original light switch controller. A few weeks ago I mentioned lights turning on and off randomly on the original light switch controller. Okay. John Smith says, why does my ESP01 stop working when I have a blackout and restore power? Sophie says, I need to build a smart clock. Any suggestions? All right, we've got lots of little things we could be chasing. Now, I am going to try opening Eagle and let's see if the universe explodes. Hopefully this will be okay, because normally I can run Eagle even with OBS running. That's not too much of a problem. And hopefully I'll have an answer to James O's question. Projects. I'm just trying to open up a board. Alright, what board did I have some proto area on? And the proto area is actually really, really crude. When you see how it's done, you'll think, oh, that's kind of laborious and silly. Alright, let's go. What board have I done recently? Oh, I know what board. The Rack 32 Proto. That one will do. R32 Proto. So for those of you who haven't seen it, let's switch to overhead. This thing. So when I got the Rack 32 done, I also had a bunch of these prototyping boards done that fit on top of it, and they pass through the SPI and I2C connections, and then it gives you a proto area and then breakouts for, so these extra headers along here, which is the second I2C and a few other things, are broken out here. Here's just a version with some headers on it. So it's got the sockets on the bottom, it's got pin header on there, and it's got a bunch of proto area in the middle. In fact, I'm going to scroll myself sideways and scroll back. So here, let's get this laptop out of the way. It is visual noise. Where can I put it? I don't have a flat surface without stuff on it. Okay, so Rack 32. This is a Rack 32 with the PoE module on it. So this is one that is about to be shipped out. And this proto thing. So it's got these IDC headers on here, and the IDC headers are just standard 0.1 inch pitch, which means I can just use normal, pin header sockets on the bottom of the PCB, and they plug in. So it goes in. That pin is bent. How did that pin get bent? And they go in like that, and then it drops down into position. So that just gives a bit of extra prototyping area. And if I put the sockets on the top here, then there would be IDC pass through. So you can still plug the IDC cables in here, and then you've got prototyping area. So the question from James O was, how do I do the proto area on these sorts of boards? All right, let's have a look. R32 Proto here. Just got to resize my window and bring up the desktop. Desktop there. All right, so this is the R32 Proto with the prototyping area just on here. And these are, what are they? Vias, basically, vias. So all they are is vias which have been set to a 1mm drill. Shape is round, and diameter on these ones is set to auto. So it derives the diameter of the exposed area from the design rules, which are set. So basically, it's just a whole bunch of vias, and if you look at if you examine one of them, you'll see that the name is just N$5 on this one. And so that's net number 5. This one will be something else, or net 3, net 24. So they're all just different. And the way to do that, there are a couple of ways to do it. These proto areas are on a 0.1 inch grid. So what I normally do is come over here, go to inch, and go 0.1, and then select the via tool, and I'm going to go for a drill of normally 1mm. What is 1mm in imperial? I can't remember. So let's find out. Now that we've switched grids, it is that. So what I could do is go via, and my drill is that, and because we've got the grid set now to 0.1, you can just go joint, 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 Now, there's a little trick. This will take ages. If you're wanting to fill out an area like this, what I normally do is do a quick row and then go new and then copy group, stick it down there, select that, copy group. Now, there's one thing to be careful of. If you copy a single object with an unnamed net, the net is duplicated and then you end up with a link between them, like an air wire between them. So in this case, if for example I did a copy of a single object, so I'm going to copy just this wire and then put it down over here, whoop, an air wire has appeared between them. And that is because when you copy, in Eagle, when you copy an object like this, what you're doing is copying all its attributes, including the net name, which in this case was net1. So when you paste it, you also get net1. But what happens is, if you copy a group of things, like if I copy, let's just say I copy 2, because these two, deselect, so that one has a net of, that's net 200, this one is net 201. If I duplicate that, copy that group, it is not going to know what nets to give it. So what happens is that it just increments, because you've copied the attributes of 2 of those objects are different. So this is now 213. That'll be 214 is my guess. Yep, 214. So very, very crude, but that's basically how I do it. I just lay down some vias on a 0.1 inch grid. And then in the schematic, so one of the reasons I do this, I do it this way. You could make an object, like a proto area object, but the problem is that then it exists in the schematic as well as the grid. And one of the first time I did this, like one of the very early PCBs I did, what I did for Practical Arduino, it was actually the Practical Arduino Proto Shield, I did it a different way. And this way is really, really ugly. So what you can do is come into the schematic, and I'm just going to bring this in here. So the alternative is, and in the schematic here, what you can see is I've put an area for prototyping area. So there are headers specifically for the power and the ground connections, and for the I/O connections on here. So what you could do is print this sheet out and then draw your circuit in here. So you could just draw transistors and resistors and LEDs, whatever you want to put in here, and then draw the connections, how it connects to the power connections and to the I/O connections, and have that as a reference, so that then when you look back on it, you can see exactly how you've connected everything up. Now, what happened with the very first thing? So let's just switch back to here. I'm going to get rid of all of this and delete that group. So now we have just the board again, and go back to here. So what you see here is a very clean looking schematic. We've got this big open area, and there are the connections for the I/O on here. But what I did on my on the Practical Arduino prototyping shield, which was before Freetronics existed, was I did add part, and I'll just move this over so you can see it. And then I would have picked I mean, this library didn't exist back then, obviously. I would have done an M01 header like this, and gone glunk, 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 glunk. Stick down a whole heap of of headers, and then switch back to the schematic. And now, oh look at this, we've got a whole bunch of headers on here. So what you could do is take these and arrange them. If you'd had a 0.1 inch grid set properly, then they should all be on the correct, they'll be on the right grid anyway, even though the spacing isn't correct. So let's move these together. So you end up with this sort of, come on. No, I've got two overlaid there. So you end up with that sort of thing. So what happens is you end up with the grid on your PCB, and effectively it's the same as this. There's silk screen on this, but you can solve that problem. But yeah, so you can create a grid like this out of discrete things like this. But of course your schematic ends up a total mess. You'll end up with a page just full of these headers that aren't connected to anything. And it's super ugly. So yeah, that was how I did it very early on before I realized there was a better way to do it. So now I do it just by laying out a grid of vias. And once you've, if you start just copying and pasting groups, basically you're getting like a binary multiple each time. So you make one row and then you double it. So you've got 2 rows, and then you copy that group and paste it, and then you've got 4 rows and copy and paste that group, and you've got 8 rows. So it only takes a few iterations, and you can do an area like this very quickly. Yes. Oh, Austin says there's a ULP for doing arrangements. Haha, cool. Yeah, so I'm sure there are ULP. So ULP is a script, user level program, I think it stands for. It's the programming extensions to KiCad. You can write your own little programs that do a whole lot of things. Because Eagle is actually kind of command line driven. So all these things that we're doing, you can actually just type commands in here like crew. Yeah, so yeah, what can we do? I can't remember. We could do route. You can, if you know the actual commands, you can just do everything through the command line, and you can script it. So you can create. I don't have any ULPs loaded, but you can create scripts that do all sorts of things like renumber all your parts, or to optimize the designators so that they're sequential instead of gaps in them after you've deleted parts, and rearrange things and change the sizes of things. So you can do like bulk part replacements, take all of your 0603 resistors and change them to 0402 in one go, that sort of thing. And it's all scriptable. Anyway, that's that. I'd spend a way longer talking about something relatively simple than I expected I would. All right, now that I've screwed up this project. Oh, yeah, an array. So Scott Miller said if you use KiCad, you can just right-click the via and select Create Array. There is an array function in here as well. Where are we? Pattern, circular or linear, item count, separation, etc. X spacing, Y spacing. So yes, you can just create arrays. You could arrange them in a circular type. Item count for let's make a clock. We'll make 12, circular, spacing in degrees. All right, 360 divided by 12 is 30, so we'll make it 30 degrees. And rotate item, why not? And what are we going to put down? How do we do this? Add part. Yeah, this is a feature I don't normally use. I don't even know how this works. Let's try an LED. Let's make a circle of LEDs. Can't back and it. Oh. Yeah. Okay. Anyway, there's a way to do it. Okay. So, and of course the other thing is that in terms of things like patterned layouts and mechanical stuff, if you do this in Fusion 360, it is way, way more powerful. It's, yeah, it's amazing. And you can make it parametrically driven and all sorts of stuff. Super cool. So one thing I really need to do is, I'm still using Eagle for my PCB layout. I'm in that period where I'm hanging off switching to using Fusion for my PCB layout because it's, yeah, there was no point jumping too early because Fusion was still very limited in terms of its board design compared to, you know, its mechanical design. But now all of their work is going into, all of their PCB development work is going into Fusion. It's not going into Eagle anymore. And so, yeah, it gets the benefit of all of the really cool CAD stuff. Like the MCAD, the mechanical CAD stuff that's in Fusion. It gives you all of that power in to do things like crazy board outlines and to do things like derive your circuit board shape from a mechanical design for an enclosure, and, you know, just project the enclosure and then give yourself clearances based on parametric values and things. Really, really powerful. So the integration between schematic circuit board design and mechanical design is like that really tight integration, all being done in the same program, is actually really cool. But I'm still here using Eagle. Now, oh, cable ties here too. Cable tie. So, Frank said, the ground plane everyone puts in their PCBs. I thought it was only required for RF stuff. Okay, that's actually an interesting point to make. So, the short answer is no. There are benefits to a ground plane, even if you're not working with RF. And ooh, this is opening up a huge topic that I could probably talk about for the rest of the live stream. So I will try to limit it. Okay, there are a couple of reasons. I'll start with the kind of boring reason. PCBs are manufactured by sandwiching a substrate and layers of copper. So if you look at the cross-section of a PCB, it's a thin layer of fiberglass. If you're talking about a typical 2-layer PCB, thin layer of fiberglass and copper on both sides. So for those of us who are old enough or silly enough or whatever to have made our own PCBs, like put the Dello pen, like polish up the bare copper with the steel wool and then draw the tracks on with the Dello pen, or use a photo transfer and then put it in a bath of ferric chloride, or, you know, whatever the thing is. What happens is that you start with a board that is completely copper, and then the chemicals etch away everywhere that is not copper. Now, one of the thing is that if you have made your own boards, what you'll notice is that as the copper is being eaten away, you end up with the last pieces to go are actually the centers of the big chunks, the big areas of copper that are being etched away, because it kind of works in from the edges to some extent. The etchant material starts to etch into the face of the copper, but as it thins on the edges, it sort of works in. It's a little bit hard to describe. I wish I had something to show you. In fact, I probably do. I've got a box up here of PCB making stuff. I know, I stuck it out in the garage, I think, because it had been so many years since I had cared about it that, oh no, it is in there. It is there. I'm going to grab down my PCB making box. Although I doubt there will be any examples in here. There's not really much left in this box. No, it's almost nothing. There's just some ammonium persulfate, some Dello pens, and some bare copper board. Although that's kind of interesting to look at. Look how crappy this board is. This board, it has been sitting in, it is years and years old. It's had fingerprints and things on it, so this would need cleaning up before using. But it's the thin layer of fiberglass and then a sheet of copper top and bottom. And then I got my old Dello pens from when I used to draw out PCB traces by hand and then chuck it in the ammonium persulfate or the ferric chloride to etch away the copper from all the places where I didn't want it. So what happens is the chemicals that are used to etch away the copper become loaded up and lose their effectiveness the more copper they eat, because the chemicals react with the copper. I can't remember the reaction, it's so many years. Anyway, there is a chemical reaction between the etchant and the copper, and it falls down out of solution as a sediment in the bottom of the etching bath. And the more copper you take off the board, firstly, the longer it takes to do the etching, and secondly, the more it uses up your chemicals. So that was a very long-winded way of saying the less copper you take off the board, the better. And ground planes helped with that. If you have a ground plane, like a polygon that covers your entire PCB, you draw the tracks on it, and then you etch away only the spacing, just the gap between the tracks and the ground plane, you're only etching away a very small amount of material. Now, the way PCBs are actually made now is the chemicals that are used in factories like All PCB and JLC PCB and all these sorts of places, they're not using ferric chloride. They're using a different etching method, which has quite different characteristics, but still the principle of what I'm talking about is the same. So the goal is to minimize copper removal, and by leaving a ground plane on the PCB, it helps with that, because you're only taking off the little separation gaps between the track and the ground pour around it. Okay. Yes. Okay, so Chris has brought up the next point, which is very important. Ground planes can help reduce emissions of RF from any circuit, also reduce quantity of chemicals needed to produce PCBs. Yes, so I've just mentioned the second point, but Chris's first point, and this is really the critical thing. The thing is that I am not enough of an expert to be able to explain this properly, but I will give it a crack. The issue is that any circuit is an RF circuit if it has fast transitions. So if you are there are some people who explain this really well. There are some fantastic videos. Just looking around, I did have a book sitting right here on my bench. Did I move it? Yeah, there's Henry W. Ott's book. I've got to remind myself what it's. Henry Ott. And there are some. Oh yeah, Electromagnetic Compatibility Engineering. This book, which I normally have sitting, it's normally sitting on my bench, like right here. I think I might have taken it into the house because I was looking at it or something. This book, which is extremely expensive, hang on, where are we? Desktop, is amazing. It's it really changed the way I think about electronic circuits. Yeah, so one of the points that Henry makes in this book, and there is also a there's another video which I tweeted about ages ago, maybe a year or two ago. True. RF. Sorry, I'm going through what would my search terms be. Energy is in the plastic. There's a PCB design. Someone in the chat probably knows who this is. I've gone blank. There's a series of videos that are just mind-blowing. They make a I can't think of the name right now. Is in the plastic. Let's try videos. There's a guy who did a he's done a number of talks at Altium Academy, and where are we? I've got to find this eventually. Richie, no. Altium Academy keynote. Maybe this will help me find it. As soon as I see his name, I'm going to think, oh, why couldn't I think of that? Anyway, what I will try to do is give a very bad explanation. So, what the issue is that transitions are what cause emissions. And if you have a, so say you have Blink. Okay, I'm going to use a really silly example here. You've got a project with a microcontroller on it, and your microcontroller is driving an LED. So if you've got an Arduino Uno with an LED and you load Blink, this is like the most basic thing possible. The default settings in Blink are a 1,000 millisecond interval. So basically it's like a 1 hertz thing. It turns the LED on for 1 second, waits for 1 second, turns the LED off, etc. Now that is super slow. What you're seeing is a signal that is going from low to high to low, and the transitions are only one transition every second. And you would think there is no way that's got anything to do with RF. The frequency of that is so low that it is just like, you can sit there and just watch it and go 1, 2, 3, like it's that slow. It's not what you would consider RF. But the critical thing is there is a transition, and what we're talking about is the rise and fall time. So if you've got a signal that starts high and then it transitions and goes low, then there is a certain period of time during which that transition occurs. And if that transition happens, I'm just going to be making up numbers that are probably an order of magnitude off, or multiple orders of magnitude off. But if that transition happens within a certain number of picoseconds, then what you are talking about is a signal that is essentially RF just for that moment. You are having you are potentially emitting into the RF spectrum, and depending on what you're doing with your circuit, your circuit could be susceptible to external signals which cause spurious inputs as well. Now, I have been bitten by this. I was bitten by this a couple of years ago on a commercial project. I was doing a project where I had a 4-layer PCB, and what I did was I had signal on the top, then I had a ground pour, then a power pour. It was 3.3, I think it was a 3.3 volt system, and then on the bottom I had signals again, but there were no ground pours on the top and bottom. The PCBs were just like bare with everything etched away except the tracks. And I was having a horrible time with the reliability of this circuit. I was getting spontaneous microcontroller reboots, like just resets out of nowhere. And I was getting bad signals on things like analog to digital converter inputs. And it was a total nightmare. I was scratching my head over this circuit, and I just could not figure out what the hell was going on. And what I was thinking is it can't possibly be it can't possibly be external interference because I've got a ground pore on layer 2 directly under the signal layer. So that means the signal layer is referencing the ground pore, and that should give it, a good deal of protection, right? It should be, in theory. And that was actually around the time that, yeah, I was puzzling over this problem. This was, as I said, a couple of years ago. And over a Christmas break, I sat down and pulled out this book, which I'd already had this book for a while at that point. And I was sitting there reading through it, and something in my brain suddenly grasped what Henry Ott was talking about. And I thought, oh, it's the transitions on those signals that are causing the interference both between signals on the same board and from external noise coming in and affecting it. Because this particular thing was operating near some electric motors, and the electric motors have got, generate strong electromagnetic fields, and it, causes all sorts of noise. So what happened was I went home. I'd been away for like a Christmas family trip, and I was sitting there on my family trip reading this electromagnetic compatibility engineering book just for the fun of it. I went home, opened Eagle, put a ground pore on both the top and bottom of the PCB, sent the files off, came back, put the parts on them, problem solved. The board was absolutely rock solid. I could not make it fault after that. The only difference was that I added the ground plane on the top and bottom. Now this is a board that was not doing any RF work. It wasn't communicating over radio. It was not using Wi-Fi, not using Bluetooth, anything like that. It was a simple microcontroller that was doing some input work, some sensors, and controlling some outputs. And it went from tear my hair out frustration, unreliable, to rock solid, couldn't make it fault, just by adding the ground planes on the top and bottom layers. And yeah, so since then I have never tried to make a board without those pores on them. It makes so much difference to just the way the thing works. So it's about short return paths, as Sion says. Yes, that is part of it. Now, I wish that I could find these videos, Altium Keynote, Altium Academy, because there are these other videos that explain the concepts of the short return paths, ground loops, and all of those sorts of things so well. I've watched these videos multiple times. I can visualize the guy giving the presentation, and it's like his name is just on the edge of my brain and I can't quite remember what it is. It might have been... He's done keynotes at Altium Academy a few times. I think he did it in 2020, 2019. Let's see. Altium Live. No, unfortunately the descriptions they put on their YouTube videos aren't that great, so it makes it hard to find them. Energy in plastic. Rick Hartley! That's who it is. Rick Hartley. If you want to have your mind blown, watch a Rick Hartley keynote. Now I'm just going to see if I can find a good example, and I'm going to stick it right here. Rick Hartley, Altium keynote, differential pairs, Rick Hartley on EMI noise reduction. This one, if I hit if I select this, it's probably going to start playing, but I will pause it. Okay, this, I'm not even sure if this video is one that I've seen. I think it might be. I think it might be. This is not the one that I was thinking of, but this particular video right here is really cool. This one, I didn't even realize I had the I was doing desktop sharing and I wasn't showing you what I was looking at. So this particular one, it's kind of an interview with him, and it was done as a preview for like a paid course. But the talk itself, so it's a 45-minute video, he goes into a lot of the basic concepts, and so there are a couple of phrases that he uses a lot, and one of them is the energy is in the plastic. So it comes down to the question of when you are passing a signal along a PCB between 2 points, you have a track and you have a ground return typically. So what I'm talking about here is a circuit. The electricity has to flow in a circuit. So you have the flow through one track and then back out through another track so that it makes a loop. And the question that Rick asks is, where is the energy? And of course, what we're used to thinking about is, if I want to pass a big current across my circuit board, I need to make bigger tracks because you get heating in the track. If you make the track too small, you can't make a really, really teeny tiny track and then pass amps of current through it, because the track will get hot and then melt and just your track won't exist anymore. So what we are used to thinking about is the energy or the power is traveling through the copper. And the big revelation for me was Rick explaining that the energy is not in the track. It's in what he calls the plastic, which is the fiberglass core of the PCB, because it is actually the electromagnetic field which surrounds the track and goes between the two paths of the current. And it's one of those things that I would not be able to explain very well, but if you watch some of Rick's videos, this is not actually the one that I was thinking of. There are other videos that he's done. There was another one that he talked about. Where is it? Differential pairs. Yeah, his PCB stack-up design best practices. This is interesting as well. So this is a talk from 2018. Anyway, if you can't go wrong by searching for Rick Hartley PCB, you know, that will get you a bunch of really interesting and useful things. And I've certainly learned a lot. Okay. Yeah, so that whole thing about the energy not being in the track, but in the area, in the volume around the track, which is where the electromagnetic field is, also relates to things like ground loops and separation of return paths, and where electrons will flow in a return path if they are given an opportunity. For example, if you have a layer which is a ground plane, and then you have a track that runs directly across the top of the ground plane, like on the top level, the level above it, the electrons will flow along the track and they will flow through the ground plane, but they won't spread all the way around the ground plane. They will flow in a line under the track, including following the track. If it meanders, they won't go in a straight line point to point necessarily, because what they are doing is maintaining the electromagnetic coupling between the ground plane and the track. And it is that electromagnetic coupling which is where the energy is. Anyway, really, really cool, interesting stuff. Kind of brain-bending, but he does a great job of explaining it. Okay, so... oh, Tony Smith came up with the correct name. Rick Hartley. Can we make a Faraday cage for that? All right, so do I have a picture of that board? Carlos was asking. I assume you mean the board of the one I was talking about, which had Sorry, I'm distracting myself here. So I'm not even sure if the ATEM is still working. I don't know if the stream is still working. Let's see. Can I see if my stream is running? Somewhere. Oh, okay, there. Let's just switch back to here. And YouTube thinks the stream is still working. Hopefully the ATEM is still working. Okay. What was I talking about? What was I talking about? I don't know. Thanks, Austin. All right. Now, there were so many squirrels to chase. Yes. Now, what other things? Yes. So Chris, Chris said, if the circuit uses square waves or transitions that are really fast, then the Fourier analysis of these waveforms shows that lots of harmonics are produced. But that's too deep for a Sunday. Yeah. So what Chris is getting at there is an extension of what I was just talking about, where it is not a matter of how often the signal transition happens. It is a matter of how fast the signal transition happens. And that's what generates the harmonics and the emissions and all of those sorts of things. So one of the points that Rick makes in one of his videos is that, so he talks about lots of interesting war stories, like jobs where he's been called in as a consultant to help a project, or help a team who are dealing with some difficult engineering project. And so he talks about, coming into an existing project and seeing all the ways things have been done wrong, or the way design decisions have had an effect on the way the device works. And one of the, where was I going with this? Yeah, well, one of the things, one of the key messages that he gets across in his videos is that it is not about clock rate, it's about transition speed. So you can have circuits that are running at relatively slow clock rates, but if the chips are sensitive to things like slow rise times, then capacitance can be a really big problem. So you might think that I'm only doing a transition at a very low frequency, but if your signals are really rough, like if you look at the signal under an oscilloscope and you see that it is not like a nice quick transition, it might be like a slow slope, that can cause problems for today's high-speed devices, because it's the angle of the slope that matters, not so much how often the slope occurs. Yeah, so anyway, let's not get into Fourier transforms. That's beyond my pay grade. Did someone say something? Did anyone else hear that voice? I don't know. All right, cable tie. It took me a while to get the joke. Sorry. Okay, here's an interesting one. Stephen W. said, did you ever get those PoE modules? And Austin's Creation said, yes, he did, Stephen W. And Austin is correct, but there is a caveat. So I'm looking around because I'm going to show you something. I've got, sorry, I'm looking up at the CCTV because I can just see that that Anne and Tommy are heading out through the garage to go on a walk, getting their COVID safe exercise happening. And I was just being distracted by all the doors banging and stuff. All right. All right. Now, Iggy made an interesting point. That's why FPGA and CPLD have slew rate limiting or adjustability on pins. If you don't need the fastest rise times, you can choose to reduce it. Yeah. Rick's videos are great. Yeah, cool. Now, I was going to talk about PoE modules. So, sliding myself over here and chucking that back there, going to overhead. So what's happened is I did the design on this for this specific PoE module. This Estapo, I can't remember the part number. Oh, it says PM3812R on it. I don't think that's actually the part number. Oh no, that's the, or is it? Maybe, I don't know. So this regulator, oh, excuse me, hang on. I've got to kill the audio. That's better. All right, so this particular module I had never used before. I came across it while I was looking for regulator modules, and I've been having trouble getting the Silvertel modules that I have generally used in the past and that I really like. Saw this, it was super cheap, and I ordered some. Now, and so I designed this PCB keeping in mind that I wanted to put that module on it, even though I'd never actually received, I hadn't received the module. I just designed the board based on the specs that I could find. And to my great amazement, when I assembled the boards, it worked. So that was a win. You can see that I got the dimensions slightly wrong. If you're looking straight down on it, I'll try to get the angle correct. You'll see that my silkscreen outline on the board isn't actually quite mechanically where stuff is on this module, and the whole module is offset this direction a bit relative to the pins. But luckily, I didn't have anything much on this area of the board except for these jumpers. So the fact that the module is offset slightly in this direction is okay. It all fitted. And electrically it works just fine. So that's the good news. The rather bizarre news is, let me show you what it was that the seller sent me. And because this was brand new, I ordered, let's see, I'm not even sure, where did I put it? I had a photo just here. Oh, here it is. I think this is it. Opening it up. Yes. All right. So what I'm going to show you is a photo that I annotated because I sent this to the seller. Desktop. Here we go. So what they sent me was, I ordered 15 of these modules. What they sent me was 5 of that module that I wanted and 10 of this other module, which is from the same manufacturer, but it's a totally different pinout. It is still a PoE module, but it is not the same module. It does not fit on the same footprint. It's not compatible, and no explanation whatsoever. And 2 of them were damaged. So what you can see down here is because they were just bundled up in bags and shoved in like a padded bag, the electrolytic capacitors, this one was off entirely and this one was pushed sideways a bit. Now the thing is, that was actually easy to fix. I just soldered this onto the PCB and it worked fine. And they came a little bit dirty, like there was still flux and stuff on the boards. Put it through the ultrasonic cleaner and they came up looking sparkly, shiny and awesome. But so what I actually ended up with was 5 of the correct module instead of 15. And so I submitted a dispute to AliExpress, via AliExpress. And the thing is that this was a double dispute. The dispute was, firstly, they sent me partly the wrong product and partly damaged. So what I was claiming was I ordered 15 and I received 3. And so anyway, the dispute ended up being resolved in my favor, which was nice. But I still didn't have the modules that I wanted. Now, luckily, because these modules were taking so long to arrive, I did place an order for more modules with another seller maybe a month ago, and they should be arriving soon as well. And I'm actually thinking about placing a 3rd order, maybe trying to buy them directly from the manufacturer, from Estapo, so that I can avoid this issue and yeah, so that's what's happened. So what I ended up with was this. This is the, you can see I've got 5 of them here. This is the entire stock of Rack 32s that I've been able to finish with the regulator modules, because this is all I've got. And so during the week, I spent 2 days this week finishing off all of these boards. I've got these, and I've got these and these. So I'm where is it? There. So I'm kind of rich in Rack 32s right now. That's it. But only these ones have the PoE modules on them. All of these others are totally ready to go and tested. So they've had all of their testing. I've tested the SPI, I2C, the SD cards, the voltage regulators, Ethernet has been tested, like all the headers have been tested. They are 100% functional, ready to go. They just need the PoE modules added to them. So I've got them sitting here waiting for the PoE modules to arrive, and when they do, they will be populated and sent out. So the reason that these 2 sets are in different racks is that these ones have the onboard PCB antenna, and these ones have the UFL connector for an external antenna. And what I'm actually intending to do, I wasn't planning to do this, but I think what I'm going to do, get in there, there it is I also ordered some other antennas. So weeks and weeks ago, I ordered these just because I wanted to experiment with them. And these are so UFL connector going to an SMA header, and then this. And I've got all the nuts and things in there. So what I was thinking of doing was including that with the versions that have got the UFL connector. So if you buy the version with the UFL connector or the external antenna, I'm actually going to include this with it. But what I'm not sure about is whether, but of course this costs me more. So in order to get these pigtails and the antenna and stuff, it costs me more to make it like this than to make the just the PCB antenna version. So what I've been debating is either list the antenna and the pigtail as a separate product. So essentially you buy that, and if you want to, you could spend $10 or something and get this, or I bundle it in and increase the price of this one by $10. So the option is either you get the one with the onboard PCB antenna, or for $10 extra, you get the one with the UFL connector and the antenna bundled in with it. Anyway, I haven't actually decided that yet. So my thought is that anyone who specifies the external UFL connector, the antenna, the reason you would want that over the PCB antenna is if you're going to be putting this in a steel case and you care about RF performance. So you want to be able to bring the antenna outside of the case. Like say you were building an OXRS rack mount enclosure and putting this inside it, and you want to use Wi-Fi, then you would want to use something like this plugged in here, going to a hole in the case, and then have the antenna mounted on the outside of the enclosure. So if you're not going to do that, there really isn't any reason to order the version with the UFL header. You'd probably just order this one. So my inclination at the moment is to increase the price on this one by $10 and bundle in the antenna and the pigtail, so that is one complete thing. Scott says, don't bundle the antenna, make it separate. Okay, cool. Yeah, all right. Dodgy says, can't wait to see if John likes his new sofa. What? There's something, I've missed something, obviously. Yeah. Right. So anyway, this all came about from a question about the PoE regulators and did I ever receive the modules. So the answer is a complicated yes, kinda. And so my plan is that, so I spent, as I said, 2 days this week, going back to here, I spent 2 days this week working on these boards, putting all of these together and doing all of the testing and washing and all that sort of thing. And so what I'm going to do is people that pre-ordered, I'm going to begin fulfilling orders probably tomorrow. So the first one should start shipping out tomorrow with using these ones that have got the regulator modules on them. And then as soon as I receive more regulator modules, I will be able to populate these other ones and start shipping those out as well. Now I'm actually going to run out of these before long, so I'm also going to be ordering more PCBs because I need to I need to assemble more of these. I only ordered 20 when I did the first version, like the V1.0, because I wasn't even sure if this was going to work. The whole thing was a big experiment. I'd never done hardwired Ethernet with an ESP32 before. This is the first time I'd ever done it. The circuit was kind of speculative. I didn't know whether the software would support it. It was all a big gamble. So I only ordered 20 boards. And the fact that everything on this board works is amazing and kind of surprising. So now that I know that it does, I'm going to order more of those PCBs and assemble some more. Now, expanding sofa. What is this with the sofa? Teeny tiny sofa. Expanding sofa, just add water. Squirrel sized sofa. Yeah, and Chris says, I would bundle it together as even a metal case will reduce the signal strength of the Wi-Fi. Yeah. Oh, dodgy. Okay, that explains it. You were guessing at what Austin sent. He said it was a sofa. Okay, now, the what are these juicy PoE modules? Mr. Fixit, hey! It's cool that you're here. Oh yes, Mr. Fixit. So this is everyone else just ignore us for a moment. Quick personal conversation with Mr. Fixit. I got your message about changing your order, and the short answer is yes, we will sort that out. So sorry I haven't replied to your, was it email or DM or something? Anyway, I got your message and I will follow it up. Sorry about that. Okay, so now that Mr. Fixit and I have had our little conversation, the rest of you can start listening in again. Now, there was a question about yes, there it is, Austin's Creations, SDARPO DP40 1435 on AliExpress. Now, let me see. I'm going to see if I can drop you an affiliate link because I am so totally mercenary. Yes. Just got to look up my parts orders. Now, what I'm not going to do is drop you a link to the first seller. Now, this whole thing comes with some major caveats. I'm just opening my AliExpress ordering spreadsheet here. Here we go. Open this. Is this going to work? All right. Yes. Now, keep in mind that what I'm going to drop you a link to here is a seller that I have not even received the modules from yet. So this is, they may not arrive. They may arrive in 6 months. They may arrive destroyed. And the seller only has a 96.1% positive rating, which is not that good. So these are the modules. But anyway, you can make your own judgment call. What you're looking for, as Austin said, is Estarpo DP1435. Estarpo is the company, and DP1435 is the model. They do, yeah. But if you search for that on AliExpress, you'll find a bunch of stuff. So you can buy directly from Estarpo. There's, oh, don't buy from here. 7 Color Lemon Store is the one that comes up when you search for it as the first seller. Don't buy from 7 Color Lemon Store. That's where I got my first lot from, and they sent me 10 of the wrong type and 2 of the right ones that were broken. Okay, so in fact, let's have a look at this one and laugh at their seller rating. Where is it? 93.9% seller rating. That is terrible. But if you look around, the people that are selling these modules, most of them have really bad seller ratings or have never sold any. Look at this. 0. All of these sellers list them with 0 sales. They haven't sold a single one. Where are we? Let's find one that has, this one has sold 2. AP25 Consumer. 3C Mart Store says it's sold to 2 sales, not 2 units. But let's look at the seller rating on this one. 94%, that's really bad. But where is this one? 89, I've never seen a seller rating that low, 89.4%. So take it with a grain of salt. So far from my limited testing, these modules seem to be pretty cool, but the issue is just getting a reliable supplier for them. And if we have a look here, if we go to Estarpo, you can see that I've already been to this link. So this is the company, and going through here, inquiry, I could make contact with them and probably buy them directly. And in future, I think that's what I'm going to do. Products, sure, because yeah, the online sellers that are selling these things are not so good. Let's just put it that way. Mr. Fixit says, sounds like drop shippers. They are absolutely 100% drop shippers. And if you, particularly when you look at the other things that they sell, like let's look at this 7 Color Lemon Store and come into their store and see what items they've got. I don't even know if I want to show it. Best selling. Oh, at least it's mostly electrical sort of stuff. But so often what you'll find is that these sellers will list all sorts of random stuff that is not like, they'll have office equipment and homewares and clothing and, oh, there we go. Here's the regulator module. This one seems to have a whole lot of camera gear. They've got random electric microphones and headphones and TV mounting brackets. So they're kind of focused on tech sort of stuff, but still, they're, yes, they burned me. Okay. Yes. So Stephen W says, will they do 30 watt PoE or only 15 watt? They'll only do 15. I think technically it's like 12.9 watts or something. What is this? I can't remember the spec. They do 802.3 AF. They don't do AT or AX, I think are the other two variations. Yes. Bad seller, but great name. Yeah, 7 Color Lemon Store. That name is awesome. What are some of the funny store names in here? Convenient 666 Store. That's a good one. electronic consumer store, medicine department store. Yeah. Ooh, produce direct sales boutique store. Cool names. Passionate life. Anyway, if you can find a good seller, then those Estapo DP1435s are worth looking at. Now, there was that question about, can it do 30 watts or only 15 watts? Let's have a look directly on the Estapo site. Oh no, I forgot to mute my voice assistant before starting. Let's see if it's going to respond to anything. No, hit mute. PoE module, 12 volt PoE module. Let's see what options they've got. So they've got, these ones are 802.3 AF. This is it, the DP1435, which is .3 AF as well. And do they have any that are like, oh, they've got an AT module here. What else? AF, doesn't say. Let's have a look. 12 volt 2 amps. So that's getting up there in wattage. What is this one? So this is AF and AT, yeah? So this one would possibly do the job. Stephen, if you are looking for a module that will do 30 watts, like 802.3 AT, maybe this one is worth looking at. That one, or anyway, you can click around through there and see what products they've got. But the one I ended up going for was this, which is just .3 AF. So, or is it 12? I think the spec says 12.9 watts. Yeah, they've said 12 volt, 1.1 amp, 13 watts is what it's rated to. So, that's 802.3 AF. Yes, Colin. Sorry about that, bad throat. So Stephen W said, I have ones that do 30 watt, but they're similar size to the ones you were just showing. Yeah, cool. So which ones are you using? Which modules? I am always open to learning about new modules. Now, which reminds me, there is a Twitter account that I've been following just for a little while now, which is a constant source of sorry, I'm just scrolling through Twitter at the moment. You can sit there watching me scroll through Twitter, although you can't see what I'm scrolling. What I was just looking for was the account. I was going to recommend a Twitter account to follow, but I think I will need to make a note of it next time I see it come up in my thread. And yeah, let's not chase that squirrel right now. Okay, Stephen, I'll have to grab a board to check. Okay, cool. Sophie the cat said, is that your computer fan whirring? No, it's actually the heating. So I've got reverse cycle air conditioning in here. I'm going to turn it off. Normally I turn it off just before the live stream starts, so you'll hear it running right now. I'm standing in front of it and the air is blowing directly at me. And silence. Which means the room will begin to cool down now. But how long have I got? What is it? It's 11:20, so I won't freeze to death in the next 40 minutes. Ooh. All right, this is an interesting question. I'm just following up on that comment. Dodgy said, Sophie, that is probably my laptop fan. I am 2,000 kilometers away and you can probably hear it through John's microphone. Is it that loud? So just before moving on to this DIN rail mounted switch thing, because that is something that's important, I want to talk about that. Carlos said, pardon my ignorance, could you please explain what this Estapo DP1435 module is for? With pleasure. What it does is allow you to pass power down the Ethernet cable and then extract it at the device end. I'm going to give a very, very quick explanation here. Freetronics PoE for Arduino. I'm guessing the URL here. Page not found. Try a search. PoE Arduino. Oh, come on. How can there be that many? Oh, okay. There will be a link to it from here. Click here to our quick start guide. No, that's the somewhere here. Here, okay. I actually made a short URL for it. All right, so this. Oh, Cable Tie says, should have been an OB, so outside broadcast. The sun is beautifully warm in Croydon today. Yeah, I think I'd be warmer if I was sitting outside right now. The insulation of this room is actually keeping the nice warmth out. So what this does, anyway, rather than go through that, I'm going to do a very hand-wavy explanation and switch back to here. So what we can do with that module is have an Ethernet switch that supplies power down the network cable, and then there are tiny transformers inside this RJ45 socket. So it brings out extra connections. There are more pins on this than on a regular Ethernet socket. Those extra pins come off the transformers, which are usually just referred to as magnetics for some reason. I don't know why, but that's the terminology. They talk about mag jacks. So Ethernet jacks with magnetics in them. And then that goes, on this particular board, the output of that actually goes diagonally from one corner to the other. It goes from here all the way up to here, to where the regulator module is. The regulator module negotiates down the Ethernet cable with the Ethernet switch, and it says, hey, I'm here, give me power, and then it regulates the 48 volts that comes in down to 12 volts. And then the 12 volts goes into this regulator, which outputs 5 volts for use on different things around the board. And the 5 volts is regulated by that little thing down to 3.3, which is used to run everything else, like the ESP, etc. So it's a system for, the module takes care of converting the 48 volts coming down over the Ethernet line to 12 volts. Yes. In this particular case, yeah, what I would normally do is drop the, probably the most useful thing. I changed what I was going to say there. I was going to say what I would normally do. Probably one of the more useful things is taking the 48 volts that comes down the wire from PoE and convert it to, say, 5 volts directly using a buck converter. But in this case, what I'm doing is converting it to 12 volts, because 12 volts is very, very useful in rack mount projects for doing things like running power out to motion detectors, which typically run on 12 volts, or to illuminated light switches, and whatever else you might want to do. So 12 volts is a useful voltage to have available for many, many different purposes. And then that can be regulated down in another stage, like a second stage regulation, down to 5 volts and 3.3 volts. Yes. Okay. Yes, and as Stephen said, it's typically 48 volts and negotiated with the switch to enable it, but the switch must support it. You can't, most Ethernet switches won't do it. You have to get a switch that supports PoE. Now, that was meant to be just a quick little squirrel to chase before getting on to, that's right, Ethernet. It's kind of related. Now, all right, now I'm going to switch back to my desktop because I'm going to go for Unify Flex Mini. Now, this thing. I do not have any of these, but these look cool, I must say. And they do seem to have pretty much universal rave reviews. It's a tiny, tiny little Ethernet switch. And yesterday I was looking at, in fact, maybe this would be a good, excuse the rustling. I'm just opening something here. So what are the dimensions of this? It says that it is, I think it's just over 100, it's like 107 millimeters by 70 millimeters by 21. Okay, it's not quite the right dimensions. The Ethernet switch is bigger than this, but this is actually an HDMI splitter. It's a totally different device, but this is just to give you a concept of size. That little UniFi switch is approximately the size of this. It's actually slightly longer and slightly thinner. It's not quite as thick, but yeah, that gives you a concept of how small that 5-port gigabit Ethernet switch is. And the interesting thing is that this switch can be powered by PoE. So what you do is connect this in. You see this socket in here, it says PoE in. That's the uplink that goes to whatever switch you have, like as a core switch or whatever. That's the wrong terminology. Let's not get into enterprise network architecture. We're talking about domestic sort of use here. So if you've got an Ethernet switch which supports PoE, then what you do is you run a cable from that switch to this one, and then this switch is powered over PoE. So this one is actually acting as like a client. So it's the PD or the powered device, and it is receiving its power from another switch, which sends it down the cable. Then you've got uplink with your PoE link, and then there are 4 other ports here which you can use for local devices. So the reason I bring this up is in relation to the whole thing about the Shelly Pro 4PM, that video that I did just recently, and the thing we played around with on the live stream. So this looks, so what I've been doing is, okay, an update on that before we fully get into that. Just wonder if I've got it here. No, I think I put the box back out in the garage. So I've had more contact since with Altico Robotics since last week. And on Friday, I got a message, because I have had many people ask me, are they Australian certified? Even though I actually specifically said in the video, no, they are not certified yet. People keep asking me if they're certified. So I sent off a question to Altico, and they said that they have already been submitted to the lab. They've done the lab testing, I think, and they have been submitted for Australian and New Zealand certification, and they're expecting that certification to come through in the next couple of weeks. And I've also been put in contact with the engineer within Altico who is managing the certification process for Australia and New Zealand. So the upshot of all of that is that let's bring that up, Shelly Pro 4PM. So the upshot of all of that is, what? Pro, yes. This should be that thing, the black thing. I promise. This all ties back to that thing with the UniFi switch. There is a point to what I'm talking about here. So this black thing here, the 4-channel relay output with power monitoring and Ethernet, you can see there's a red Ethernet cable here. This is almost certainly going to be Australian approved within a matter of weeks, which is really, really cool. Now, what will be very interesting is whether the Australian approval has any caveats on it, such as requiring the Ethernet port to be blocked and not used. Now that, potentially, is a killer. That's a really big thing. Now, we actually saw something similar to this with the Sonoff what was it? The TH16. So the Sonoff TH16 has been certified for use in Australia, and it was certified by, oh, Sophie said, what are those red and blue ones? I will get to that in just a moment. I have some of those on the way to me. They're actually they're in the hands of DHL, coming to me right now from Bulgaria, which is where Ultico is. So after I did that video talking about the Shelly, like the black one, which is the Pro 4PM, I got I think it was the next day, I got a message from DHL saying, a shipment is on its way to you from Ultico Robotics. And so I got in touch with Ultico and said, what are you sending me? And they said, yeah, they're sending samples of their other Pro line products as well. So I'll get those very soon, and I'll have something more to show you. So these are, the short answer, Sophie, is that these are single channel versions that have different features. So the black one has a screen on it, and it's a 4-channel output with, it's a 4 relay channel output with power monitoring. And then they have other versions that are single channel with power monitoring and without power monitoring. So there are different variations. These ones don't have displays on them. Yeah, the display is one of those, oh wow, that looks cool things. But it's inside your switchboard, and your switchboard is closed. And how often do you look at your switchboard? The answer is not very often. So, yeah, so the screens are cool for debugging and setup and that sort of thing, but in normal day-to-day operation, you could go months without ever looking at that screen. So it has limited benefit. Now, so these little ones are single channel with no screen. Anyway, I will have those to test probably this week. They'll arrive, which is very, very cool. These ones are not yet Australian certified either, but once again, they should be soon. Now, getting back to what I was saying, let's have a look at Sonoff TH16, I think. Let's have a look at this. Now, these things. So this particular Sonoff model has a socket on the side of it where you can plug in, the reason it says TH is temperature and humidity. You can plug sensors into the side of it. It's got this, it's actually a 3.5 millimeter, I think 4-pole, like a TRRS connector in the side, so you can plug in sensors, either a temperature and humidity sensor or just a temperature sensor like a DS18B20 base sensor. Well, here's one with the temperature sensor plugged in. Now these were certified for use in Australia a couple of years ago, and Sonoff TH16 Australia certified. Okay, what's the name of the company? CTIC, so I'll find it somewhere. This is where my my poor memory for names comes in. Australia certification, maybe. Sonoff. There was a company in Melbourne that. Oh, what's this? There's a change.org petition. Oh, Oikotech. Yes, there it is. Daniel from Oikotech. So Daniel did this. Let's see. Oikotech. Here we go. Sonoff Power R2, and there is also the where are we? Products, like maybe, oh, automation. It'll be in here, automation. So there is a point. I'm getting to a point here. Eventually, one day. Products? No. Where did it go? Let's see if we can find. How do we do a search on this site? Yes, accept cookies. Search. Is there a search on this site? It doesn't look like it. Home automation. Anyway, Daniel paid for, because the thing is that the Australian market is so small as a percentage of what IT'd sell for the Sonoff that they just don't care. Like, it's not even on their radar really to get the Sonoff certified for use in Australia. They do not care. So Daniel from Oikotech took it on himself to go and get these certified. And so what he did was he got some, I think there were 3 models. There was a Sonoff Basic, Sonoff TH16 and the Sonoff Power. He sent them off to a lab, paid for the lab testing, got them certified, paid for the certification, which costs a lot of money. So now, if you buy them from him, but only from him, because they've got to... Anyway, let's not get into that whole complicated thing. Widget did not load. Okay. Anyway, if you... I've been talking for the last 10 minutes without actually explaining anything. All right, I'm going to use this as an example. You see this sticker on the side? So this is the Sonoff Power R2. Sonoff Power R2. I'm going to bring that one up, not on the Oikotech site. Here we go, look at this. You see this thing here? There's a hole in the side of this. Sonoff Power R2 Wi-Fi Smart Switch. That hole is the hole that you plug in the sensor for the temperature and humidity sensor. And what happened was that when Daniel submitted the Sonoff Power for Australian certification, the lab... Oh, is there a... Oh, here's one of Pete. This is Pete Scargill. So if you don't know Pete, you should go and check out Scargill's tech blog. He's got really interesting stuff about home automation. So this is an inside view of the Power R2. Now where is the socket? Somewhere in here. Don't know. Anyway, somewhere there on that board there is a 3.5mm socket. I will get back to the point, I promise. So what you see here is as it comes from IT'd. It's got the socket on the side for the sensor. So Daniel from Oikotech submitted the Sonoff Power for Australian certification, and he could not get it certified because of that hole in the side. And it's in relation to an isolation between mains and the SELV, like the safe extra low voltage connections, the external connections for the sensor. The only way he could get it certified was to put a sticker on it. See that Oikotech sticker on the side? It covers the hole that is used for the temperature and humidity sensor, and that actually makes it legal to use this in Australia. Because if you have the hole in the enclosure where you plug in the connector on the side, it is not possible to pass the Australian standards for certification. Alright, so this is what has got me slightly, just a little bit, worried about the Shelly Pro line with their Ethernet connector on them. And if Daniel could not get this one certified with that hole still exposed, the funny thing is, it is literally just a sticker. That hole is still there. The connector is still there on the inside. This Sonoff is exactly as it comes from IT'd if you bought it directly. The only difference is that the top sticker has been replaced, and they've put a sticker on the side to cover the sensor hole to make it compliant with Australian standards. If you peel that sticker off and use the sensor, it is no longer compliant. How silly is that? It's a crazy situation. So anyway, bringing us all the way back to this thing. So the Sonoff, the Shelly Pro line have an Ethernet connector. Now you can see here, see this big bundle of blue cables, the neutral connector cables coming in there. And there's a blue one here, that's another neutral cable. Well, the fact that this Ethernet socket is right here next to a connection where mains comes in, that may be enough that it is not possible to get this certified in Australia unless the Ethernet socket is covered up. Now that would be a really, really sad thing, and I hope it doesn't happen. I really hope that Altaco are successful in getting this certified with Ethernet enabled. Now that introduces some other issues. Issues of insulation rating on the Ethernet cable, on physical separation between LV and SELV cables, all of those things. I'm not going to get into that right now. Yes. Now, what, okay, sorry, I'm just trying to catch up on the chat because I have not seen most of what's been said for the last 10 or 15 minutes, and which is usual. Anyway, Dodgy says, so if you use it for its intended purpose, it's illegal. Sounds about right. Yes. Now, Stephen made a point, which actually ties into one of the next things I was going to get to. So, Stephen W. said, Ethernet magnetics means that the port wires are technically isolated from the device, as a question. Not really. What happens is that you, in order to comply with the standard, you are required to implement isolation in the conversion circuit. So I may be slightly misspeaking here. This is like not necessarily 100% technically correct. But the general principle, as I understand it, is the connection that comes out of the Ethernet connector needs to be isolated in terms of its power linkage to the rest of the circuit. And typically, and you can get PoE regulator modules that are either isolated or non-isolated, or maybe isolated if they are installed in a certain way. So with the Silvertel PoE regulator modules, for example, in the datasheet, it actually specifically says that you need a certain amount of physical separation on your circuit board between the input side terminals and the output side terminals. So you need to have a gap in order to achieve the isolation, and they're typically rated to like 1,500 volts of isolation between the input side and the output side. So there are a couple of situations that you want to protect against. One is you have a device installed, which is a powered device, and it's getting its power down over the Ethernet connection. In fact, this applies just for Ethernet in general. This is not necessarily even for PoE type devices. And in your wall, you might have a mains cable and an Ethernet cable. Now, they're not meant to run directly next to each other. That's, in Australia at least, that's against the regulations, and it's a bad idea for interference anyway. But they can cross at right angles. So imagine in your wall you had an Ethernet cable that was running horizontally through the wall, and you had a power cable, like a mains cable, that was running vertically. They pass each other, and someone gets a hammer and a nail, and they're hanging a picture, and they put a nail through, and they spike it straight through that joint, and they skewer the mains cable through into the Ethernet cable, and all of a sudden you have 240 volts on your Ethernet cable. Whatever is on the other ends of those Ethernet cables is probably in a whole lot of trouble. So that's the sort of scenario, as far-fetched as it seems, that these standards are meant to mitigate against. And the other thing is against the other way around, having a device that is running power over Ethernet, and then you somehow have something go wrong, like a similar crazy situation. You apply mains power to the device. You don't want that going back down the Ethernet connection and maybe making stuff catch on fire somewhere else in the building because it's connected to the same Ethernet cable. And so the PoE regulator modules typically implement, most commonly, there is a standard for it, I can't remember the number, but typically it's like 1,500 volts of isolation between the input and the output side. But that's not implemented in the Ethernet connector. it's implemented in the power conversion circuit. Maybe I'm totally wrong and I'm telling you the wrong thing. Maybe. Okay. Oh, ETIT says you can get double shielded an armored Cat 6. Yes, you can. Yeah. All right. Now, getting to the point of this, because the question from Stephen ties directly back to my whole point of bringing up this Flex Mini in the first place, is I've been looking at the Australian standards in terms of how switchboards have to be wired up and the isolation requirements. And there are a couple of things that we're going to have to do. Firstly, we're going to have to make sure, okay, so assuming that these devices end up certified and we can plug Ethernet into them, the Ethernet cable is going to have to be rated for mains voltages. Like, it has to meet the same standards as the mains cables that are within the switchboard, because it is directly in proximity to them. And so, as far as I can tell, the only twisted pair cable that has gone through that certification process and is approved for installation inside switchboards is C-bus cable. So what we can do is make up Ethernet patch leads using C-bus cable, which is, even though C-bus is not Ethernet, it is technically Cat5e cable with a higher insulation rating on the sheath. So that's the pink home automation cable that you see in some systems. And that cable is rated to a sufficiently high insulation, like the insulation rating on it is sufficiently high that it can be installed inside switchboards. So yeah, patch leads made out of that pink C-bus cable will mean that it complies from that respect. Then there is also separation between SELV and LV cable, like physical separation. That's going to be harder to achieve. Let's gloss over that right now. But then the next thing is isolation between what's inside the switchboard and the rest of the network. And that is where these come in. Now, I'm still not sure if this actually achieves the goal, but this is what I'm thinking. This is just the current concept, and we'll see where this goes after more discussions with Altico and my electrician, who so my electrician does industrial automation and knows a lot about this sort of stuff. So he's really good in terms of figuring out ways to do this in a safe way. So this is my concept. Bring Ethernet from my rack on a patch lead that is made out of the C-bus cable, so it's got the sufficient voltage rating. That will pass to a socket. Well, when I say patch lead, it'll be wired with that cable. It comes to an RJ45 socket, like an AP8C socket, a wall socket inside the switchboard enclosure. So there will be a socket that is permanently mounted, and it's enclosed. Then a patch lead made out of C-bus cable would go from that socket to the PoE in connector on this Ethernet switch. So the Ethernet switch will be powered from outside the cabinet. There'll be no need for a power supply, like a plug pack wall wart sort of arrangement or anything else to power the Ethernet switch, because the power comes in on the cable from an external PoE switch. Now, the isolation, the PoE isolation on this is rated to, I did look up the data sheet, it's a bit higher than 1.5 kilovolts. So anyway, there is isolation on the PoE port on here of 1.5 kilovolts plus, which then helps provide a bit of a barrier. So that's like an isolation point. If things go wrong inside the switchboard, that should provide a bit of a safety barrier to prevent that then passing out through the Ethernet cable going to my main rack where the other Ethernet switches are. Then patch leads, once again using C-bus cable, going from these ports to the Shelly Pros. So plugging into the bottom of it there. That means that all of the Ethernet that is inside the switchboard would be carried on mains rated Cat5e cable. The Ethernet switch which is within the switchboard is powered by PoE with 1.5 kilovolt isolation, and then the cable that goes out of the switchboard is also rated for mains isolation. So apart from the physical separation things, I think that scheme will give the maximum possible safety, the isolation between what is inside the switchboard, which is a big metal enclosed box, going to Ethernet, and then from there Ethernet going out to the rest of the home automation network so that it can send commands to this. Anyway, that's kind of how I'm thinking about it. Oh, so PTI Fisher said just use short optical fiber switch. Yes, I've been looking at that as well. So what we could do is run optic fiber into the cabinet, and then and I could do this using basically what I need is an Ethernet switch with a fiber port, like one that I can stick a module into and run fiber. Couple of things. Firstly, the price goes way up. Secondly, physical size goes way up. The Ethernet switches with the necessary ports for doing fiber are physically usually a lot bigger. Third, power becomes a problem because you can't deliver power over fiber, unfortunately. I wish we could like have teeny tiny little solar panels inside the powered device and send some light, like laser some light down, some energy down the fiber, and then power up the device at the other end with no electrical connection. That would be awesome. But it would mean that I would need to find a source of power. Now, I mean, it's inside the switchboard, so we could just put a GPO in there, of course. But it means that we'd need some kind of a plug pack, which then powers the Ethernet switch. So I've been, that is a good idea. It's an interesting idea. And I've been thinking about how to make that sort of thing work as well. But I'm coming back to the idea of using this because I think this will give enough electrical isolation that it will be all right. And how do I close this? Check this out. Well, oh no, this is US prices, but it's $29 US for one of these Ethernet switches. A 3-pack is $85. In Australian terms, these are about $50 each. So a PoE powered 5-port Ethernet managed gigabit switch is $50, which is just amazing. It is so cheap for what this thing can do. And you can buy them in 3 packs. I think it's about $130 or $140 to buy a 3-pack of these switches. Well, yeah, such good value for what they do. Yeah. Hey, look, it's almost time, which means I need to drink. Has anybody been talking about lunch yet? Oh, Sion, I don't know if you've already gone, but thanks for coming along. Okay, so Simon asked, Shelly mounting would need to be done by electricians or is DIY? In Australia, it would have to be done by electricians. I'm thinking to the New Zealand standards. So this is in terms of decreasing levels of restrictiveness. Australia is extremely restrictive, and it would definitely have to be installed by an electrician. There's just no question about that. In New Zealand, you can do some of your own work yourself, but work inside a switchboard, I think from memory, still has to be done by an electrician. Like in New Zealand, you're allowed to do things like replace light switches and light fittings. You can't do that in Australia, but in New Zealand you can. But I'm pretty sure that in New Zealand, you still can't touch anything inside the switchboard. That is still the domain of the electrician. In other countries, like I think in the US, for example, it's very liberal about this. You can actually rewire your own switchboard, like as long as you're vaguely competent. And I'm not even sure what the inspection requirements are. But in many countries around the world, you can just do all of this work yourself. There's no question about it. As long as the devices that you're installing are approved and are considered, safe and suitable, there is not a restriction on who can install the device. In Australia, there definitely is. Mike said, I like how DIY became DUI. Probably shouldn't work on mains while drunk. I don't like to work on mains at all. Yeah, so, Gil says, Switch Flex Mini AU $58 on eBay. It's actually cheaper than that if you just buy it from places like M-Wave. I'm just going to try this. M-Wave Flex Mini. Let's try it. Yeah, look at this. Look at this. Desktop. Here we go. Ubiquity Networks Flex Mini, $48 from M-Wave. And this is the 3-pack, $149. Although I have a feeling, and also something else I should point out. If you look at the pictures of the back of this thing, there is a USB-C socket on there. That is because this can either be powered from the power over Ethernet thing, or if you want to ignore that and just use it as a regular Ethernet switch without a source of PoE power, you can just plug a USB-C thing in here like a phone charger and power it off that. And I think if you buy the single version for $48, it comes with the charger. Does it? I can't remember. I think it might come with a power adapter. Where's the in the box thing? And if you power supply 5 volt 1 amp power adapter, but is that supplied? I don't know. I have a feeling that if you, yes, here we go. 5 volt 1 amp USB-C power adapter is included. So when you get this, when you buy this thing, you actually get a USB-C 1 amp power adapter with it, which is amazing. And then, but if you buy the 3-pack, so it is more expensive to buy a 3-pack than to buy 3 of the 1-pack. And if you buy a 3-pack, I'll log off now. I just got a message telling me to end my stream. 12 p.m. It is time. So yeah, if you buy the 3-pack, it is actually a couple of dollars more expensive than if you bought 3 1-packs and you don't get the power adapter with it. So yeah, the logical thing to do is just buy a few of the 1-packs. But anyway, in round numbers, like the hand wavy me style of talking thing. Oh, look at this! It gets cheaper if you get a 5-pack. It's $219. What weird pricing they've got here. So in that case, it actually is cheaper to buy it as a 5-pack than as 5 1-packs. Anyway, in very hand wavy numbers, $50 each. Like, let's just use that as a number. Australian figures, $50 each. US numbers, $30 each. It's in that ballpark for a 5-port managed gigabit Ethernet switch with PoE. Yes. Oh, Peter, yes, it was from you. Peter actually scheduled an SMS to send to me to say to get off the live stream. Oh, all right. Oh, Colin said, until you get charged 3 times shipping on individual units versus 1 shipping for the 3-pack. Yeah, let's add to cart and check out. I don't want it to show my shipping address, but let's change this quantity. No, I'm going to leave quantity as 1, postcode. Select shipping method. E-parcel okay, so courier delivery $16.95. Now let's see what happens if I make it 3. Update. And then calculate shipping to here. And shipping is the same. Okay, cool. So unless we went over some weight limit or something, it looks like the shipping wouldn't get any more expensive if you buy multiples of them. So that's cool. All right. So Simon asked, any restriction using Shelly in plug 240 volts and using it in a separate box? I'm not sure. What that question is in relation to, like how that works. Putting the Shelly in a separate box? Yeah. Don't know. Sorry, I don't quite understand the question. But as Peter's scheduled SMS said, it is lunchtime. Oh, Chip said, I'm just scrolling back through chat. So Longflare said, I said hunch by typo and it was about a coffee before lunch. All right. Yeah, so the reason I brought this up partly is that what I'm thinking about is how to DIN rail mount Flex Mini. Now I found a couple of 3D printed options for it that aren't all that pretty. So maybe some of that 3M adhesive, you know, like the stuff that's like Velcro, but it's not. It's got little plastic things on it that are like tiny mushrooms and they interlock. It's like Velcro, but if Velcro was like fed steroids and went to the gym for 12 hours a day, that's what this 3M stuff is like, the double grip thing, and it's got some kind of an adhesive on it that is insane. Like you stick the Velcro, this stuff, onto something, you can't get it off again. It's like bonded for life. So anyway, what I was thinking of doing was using some of that like double grip 3M Velcro type adhesive on the back of this and just stick it on the inside of the enclosure in the switchboard. That's one option. Or to make up a little bracket and actually clip it onto the DIN rail, which I think would be quite cool as well. Anyway, that's just where I'm thinking at the moment. So I need to do some more investigation. I need to talk more to my contacts at Altico about the Australian certification. I need to talk to my electrician about all of this, about how to do it in a sensible way. So if we can figure out a way to do it where we can install these in my switchboard, convert my switchboard from those DIN rail mounted relays to something like these, the Shelly Pro 4PMs plus Unify Ethernet switches. What I will do is make a video about that and talking about the specific regulations and how to achieve it in the switch, like how to achieve compliance in the switchboard. So what I'm hoping is that my electrician is going to be okay with appearing on video. I'll see what he says about it. In the past, what I've done is he has done the work and I've just like shown results and talked about it. But I've never actually had the camera running with him here working on stuff. And I'm not entirely sure if he'd be comfortable with it, but I'm going to try. That would be cool. So yes, Richard said, lunchtime, it's 3 a.m. here. Go to bed, Richard. You need to be asleep. All right. Speaking of, I really should end this Outbreak Day live stream. So I hope that you're all managing to endure and survive. That is such a silly tagline. Yeah, the Jackson people definitely got the... Oh yes, Austin reminded me, next week will be extra awesome, hopefully. Yeah, so we should have the package from Austin. It should be here in my hands before the live stream next week. So I will do some opening of that package. It's going to be hard to not open it in advance because Austin I know some of the things that Austin has sent, but there is also stuff in there that he hasn't told me, because I think he wants to get my reaction to it on the live stream. And it is going to be very tempting to open the package in advance to find out what's in there. But I'm going to, yes, the new couch, that's what it is. But I'm going to resist the urge. So I might have to do a little bit of preparation for next Sunday, so that the actual reveal of whatever is in the package is is good. All right. Now, one final thing. So this whole live stream, I have been streaming using the ATEM Mini Pro coupled with OBS. And it is not ideal because at the moment my audio is going directly into the ATEM. I need to fiddle around with the config a little bit more. What it means is that I can do things like switch to desktop and overhead and these inputs and things. This is all being done by OBS. So all of the compositing and overlaying, like when I go to desktop, for example, you've got the overlay with the camera there. Where? There. The camera there, overlaid on top of the desktop. All of this compositing is being done in OBS, but OBS is not actually streaming this right now. It is being captured using a display link adapter going into the ATEM Mini Pro. So I've got basically like a virtual screen that is being captured by the ATEM, which is doing the streaming. So it's doing all of the encoding, etc. And so far, I think it's worked pretty well on this stream. An Englishman in Brazil just made a comment that is held for review. I'm not going to show it, but I can read it because I can preview it. So talking about something bad that happened to Dave Jones when he did an opening. No, I hope that didn't happen. So Austin, I hope you did not put anything in the package that is going to embarrass me. Okay? I'm trusting you, buddy. Yes, I will open the outer package. I will read the note. I will leave what's in it. And then we will open it on the live stream. Don't embarrass me, please. If you put something in there that is going to embarrass me, give me some warning. Yeah, so I need to... cool, thanks Austin. Absolutely not. Most people probably have no idea what I'm talking about there, because there is that comment by an Englishman in Brazil that is moderated, and you can't see it. I can see it, but you can't. So now, yeah, I need to fix up my audio setup. At the moment, the receiver for this radio mic is going directly into the ATEM, and I've got no way of getting audio from my computer into the ATEM. I will figure that out. We'll sort it out. These things can all be fixed. The important thing is that ATEM seems to have done a decent job of running the stream, so it's doing all the encoding and pushing the data up to YouTube. So, with that, I am going to go and grab myself some lunch, and you should and you should either go and get lunch or have dinner or have breakfast or be asleep, depending on where you are in the world. So, happy Outbreak Day. May your survival be long and your death be swift. And I might go and play some Last of Us. It's Outbreak Day, so I have to play The Last of Us on Outbreak Day. It's the law. All right. Now, how do I end this? Because I'm streaming off the ATEM, I've got to end it off the ATEM. All right. All right, Dodgy. I will see you all from the news sofa next week. So I think I have to end in OBS and then end on there. The disaster continues. See ya.